Hi everyone. It's me, Yomna Abdurrahman from the Bundeswehr Uni in Munich in Germany. Along with Fatimi, we shared the posters. And on behalf of everyone, thank you very much for the organizers for organizing this. Thank you for the authors for submitting. You actually the reason why we have this interesting session. And thanks for attendees, of course. I'm sorry for keeping you from the food, but I think it's interesting and it's worth having a break between showing and asking questions. Also, I would like personally to thank Fatimi. She was the active chair, I would say, throughout the submissions and reviewing and pushing things to get the reviews out on time. So thank you very much, Fatimi. It was a pleasure working with you on this. And with that, we have 7 posters for the sessions and 2 demos. The first one, so we're gonna go with the program as the website. So basically, you can actually already access the material online. And with the first one, we have a poster all the way from Japan. And excuse my Japan ill proficiency. I'm sorry if I pronounce the names wrong, but hopefully it will not be entirely wrong. And with this, we start with the first posture through the mirrored space, where the authors looked into how to mirror the VR experience for the audience. And with this, I leave the floor to Haruki Usiada. Hopefully I didn't get...
Presentation.
Yeah, please do.
Okay. We have a developer display that projects image through a mirror with a depth perception. Eiselstein et al. Showed that the illusion of a virtual body ownership, so we can call IVVO, generated by the rubber hand illusion, is due to the intersensory correlation between vision and haptic sensations. Latstick et al. Showed that this IVVO correlates with the reality of the VR avatar's appearance. From this, we can say that the IVVO is largely generated by in the observer's own reflection through the mirror. In other words, the inverted space behind the mirror is one of the VR spaces that generated a strong IVVO. We attempt to display virtual objects in this space and provide an AR experience with the observer having a sense of body ownership. Alice is a simple AR display consisting of a half mirror and a display. As shown in figure, the half mirror is placed at the bisection of the line segment connecting the target location of the AR and the LCD. Since the half mirror and LCD are covered by a light shielding box, the LCD is hidden. The image on the LCD has fixed coordinates in the mirror world, like Pepper's ghost. So the observer perceives the image as existing in the mirror world by a motion parallax and a binocular parallax. In this project, we use Alice to show an avatar in a mirror with an IVVO. As shown in the video, we conducted an experiment in which the user interacted with an avatar to evaluate the usability and its advantage as a display. We considered the quality of the relationships that occurred between the service provider and the user. To measure presence and service quality, the questionnaire asked questions on a 7-point Likert scale regarding coexisting presence, enjoyable relationship, personal relationships, satisfaction, loyalty, and word of mouth intention. There was a significant difference in telepresence. This implies that reality is on the mirror image side. There was also no difference between Alice and VR, but there was a difference between display and Alice. It is thought that from the result of telepresence, we can say that we are able to give a sense of existence. Considering the component of a rapport, the fact that no significant difference appeared between VR and Alice for enjoyable interaction and personal connection. So these suggest that information provided by the interaction service. In terms of satisfaction level, there was an advantage between Alice and VR and between Alice and display. This suggests that user may have a perceived value in having human-like service provided by an avatar with a strong presence. Our proposed display method can provide a service satisfaction that is better than the conventional VR space. Moreover, it can experience with the same accessibility as viewing digital signage. As for future work, we plan to develop a system that supports user interaction through motion tracking and stereophonic sound and to conduct multimodal user evaluation. We are looking forward to discuss with you at poster number 1. Thank you.
Well, thank you very much for the interesting presentation and for the interesting submission. So we have one question to start with from our side. It's from Fatime. We were wondering, what is the real-world applications that could be used, like your tool could be actually used for?
For example, so so we can use any for telepresence human service. So
for example, to make some conversation with some VR characters in real world without using some head-mounted display or kind of wearable things.
So do we have any questions from the audience, live or virtual? So I think this is it for this poster. However, there is a special breakout room for that. Please try to reach out for them for like further discussions or like for more detailed insights. Thank you again very much. And this gets us to the next poster.
Thank you.
Artifact, a UML-based framework for model-driven development of interactive surface prototypes. And this actually, it was really interesting for me to read through the submissions. And I'm really looking forward on how they actually build a platform to enhance the prototyping of interactive surfaces. And with this, I leave the floor for Everett from Germany and Florian from Denmark to present their work.
My name is Everett. I'm told I have 5 minutes, so I'll try to make this quick. And I hope I am clear and everyone can hear me. My name is Everett, and together with Florian, we would like to introduce Artifact, a UML-based framework for model-driven development of interactive surface prototypes. On one hand, in our community, we have seen the accelerated accumulation of almost near identical interactive service prototypes, in particular over the last 2 decades. And on the other hand, there is this gap between the originators of concepts and future developers. And what I mean by that, it is becoming increasingly difficult to replicate prototypes. And this is also something that has been underlined by several studies. To mention one is open source, open science, and the replication crisis by Echler et al. In 2018. To sum it up, what we argue is that one of the main reasons why there's this gap between the originators of concepts and future developers is because there's no shared view. There's no common way of actually seeing prototypes in terms of implementation and specifications. So to mitigate this gap, or to bridge this gap, what we propose is a model-driven approach where we take one possible approach that proposes using models as end products for research to promote replication. What we've done so far in this direction is, over the last 2 decades, we've collected a number of artifacts, meticulously selecting them against a specific criteria. And our goal has been quite fundamental, which is to analyze the different prototypes, which at face value may look similar but are not, and to identify common underlying concepts and their relationships. More generally, maybe the ontology between the components across different domains. And by different domains, I specifically mean the hardware, the middleware, and the software. And one approach, or our main approach so far, has been to come up with a UML-based framework. Now, we understand fully that there are very many different opinions about UML across different disciplines and throughout research, but we picked UML in particular because not only is it intuitive to rationalize, it is also visually, it's also really consistent and widely known, even outside the space of computer science. And so what we've done is we've come up with...
Everett, I'm really sorry to interrupt you, but we cannot see your slides. Or, I mean, it feels that you're pointing to something, but we cannot really see that.
I see. Okay. Technical issues. Give me a second. I apologize. Thanks for pointing that out. Oh, all right.
Yeah. Oh.
All right, 5 minutes, so I'm gonna quickly try and go through these again without the words. So this was the first slide. No one missed out on anything because the whole time I was talking, there was this one slide on, so I promise we didn't miss out on much. But this was to highlight how similar the interactive service prototypes really are in our community. And this is when I was talking about the accumulation of collecting a knowledge base over the last 2 decades of existing artifacts. And this is what we kind of propose, a very high level overview of the model that we propose for capturing and expressing interactive service prototypes, something that we can use tangibly in our papers, in manuscripts and research to kind of bridge the gap between designers and future developers. Summatively, or in summary, the artifact framework we propose constitutes of 3 meta models. And just as a quick reminder, a model is typically an abstraction of a concrete system, and a meta model is an abstraction of a model. And in this case, the framework we propose is an abstraction of models that we've created out of multiple models from existing artifacts and literature. What we've done so far in the direction of evaluation is look at new artifacts, so to say, over the past 3-4 years, and try to express them using this meta model. Not only did we stop there, we also invited industrial experts and also experts in academia, and we sat down with them over interviews where we discussed whether or not it made sense to have such a model-driven approach to modeling interactive service prototypes, and also, if any, what impact would it have in helping us bridge the gap between designers and developers and mitigating the replication crisis. More on that in the breakout room. I do apologize if I spent more than 5 minutes, but thank you for helping me fix that.
So thank you very much. You were actually engaging to the extent I didn't know if you have slides or not. You were really into the topic. I wasn't sure until at some point I felt, no, there is something missing. So thank you for the enthusiasm in the presentation and for the work. We have questions from Fatimi, please. The floor is yours.
Thank you. Thanks for your talk, Everett. I just had one question regarding how did you come up with the model? What was the initial set of construct that make you make this model, basically? If you can elaborate on that.
So I particularly have a background in electrical engineering, and having studied electrical engineering for years and years, you develop a terrible habit. When you come into a new domain, there's always guidelines that kind of help you, not rigid guidelines, that kind of help you pick up and hit the ground running, so to speak. So one of the things that I was supposed to do when I came to this research space was implement middleware, hardware, and software, but combine them. So I typically looked up a way to analyze artifacts and prototypes and discovered there was no common way. And soon enough, through the research efforts together with Florian, we picked up that there are a lot of reoccurring implementations and people use the same hardware, different software, same software, different hardware. It looks alike, but it's different. And soon we picked up a lot of people are repeating the same, it's perpetual mistakes. So the idea here was, is there a way to a way that's flexible enough to capture a variety of artifacts at the same time, consistent enough to unambiguously communicate specifications in a very intuitive manner. So this is how we arrived with what we have.
I see. Okay. Thank you.
You're welcome. Thank you for the good question.
Do we have any questions from the audience? Okay, then one maybe last question from my side. Did you consider, so I have no idea about the team behind the project. Sorry for that. But did you consider to consult a software engineer in that?
So actually, we have. What we did is we came up, this is an iterative process, so this is not concrete, it's work in progress. And so far, we've sat down with not only software developers, but experts from both academia and industry. And it's the model-driven approach that we propose using model UML it's received quite a bit of critique, but which has been constructive towards this can be better and this can help bridge the replication crisis to some extent, or it can at the very least, bring the topic to the table so that people have something tangible they can discuss about towards mitigating that. And what we see in terms of the models that we're going to discuss for anyone who joins the breakout rooms, it's the cumulative contributions of multiple experts and not just our perspectives as researchers in academia.
Cool. Thank you again very, very much. Please find him in room 2 for the more details and insights and engaging sessions. Thank you very much. And this pushes us to the third poster, which is designing an augmented reality system to facilitate remote collaboration for Novoice users. And this came from France to us. And the floor is, I think, for Charles. If I'm not mistaken, he's the presenting author. Yeah, I'm not mistaken.
Yes,
cool.
I'm
The
here.
floor is yours. Please don't forget to share the slide.
Sure. So thank you for the introduction. As it was said, I'm going to present you the poster about Distant Assist Cursor, also called DAC, in behalf of my co-author. And I'm going to speak about augmented reality and remote collaboration. And when we mention augmented reality and remote collaboration, we often think about costly hardware or HMDs or handheld devices, and often also complex calibration phases, because it's not that easy to align virtual objects with physical ones, especially when it's not collocated. And these limitations about price, about the complexity, may stop novice users from using augmented reality. However, augmented reality is a really promising tool in itself. And moreover, with the current pandemic situation, well, remote collaboration is even more needed. So to address this issue, we designed a system based on the do-it-yourself approach, where we focus really on simplicity and we really target novice users. And to do so, we selected 4 principles that we wanted to work on. The first one is the accessibility. So we really wanted something low budget with commonly found hardware. And the second one was the notion of comfort. So body-worn hardware may not be really suitable for novice users, for instance, where we kind of still cumbersome HMDs or feeling some physical fatigue because of, well, you know, the weight of the handheld tablet, for instance. So we wanted to exclude these kind of devices. We, of course, wanted something usable for novices, so adapted to their knowledge about augmented reality and their needs. And also wanted something easy to set up, so a straightforward calibration easily be done entirely by these novices without external help or and so on. So to do so, we focused on projection-based augmented reality, and we focused on something really simple first, so sharing a virtual cursor. And you have here an overview of what it looks like. So on one side, you have the remote helper working on a standard workstation, so traditional computer with a keyboard and mouse. And this user is able to point at objects on a video stream. So far, so good. And on the other side, we have the local user, working as usual, but this person can see a virtual cursor which reflects the position of the mouse cursor of the remote helper. This principle is not new in itself, of course, but the novelty of our work here is the simplicity of the design, because to realize this, to achieve these results, we only use basic elements, so basic bricks. We use a projector and a camera which are co-located. And beyond that, they share the same optical center. This is the whole goal here, because if the camera is mounted directly on top of the projector, we can make the interaction and the projection plane really aligned. And this removes many parallax issues by design itself. And it also allows a straightforward calibration phase for end users, because basically they have just to click on the corners of the projection area on the screen. And that's it. We can simply, on the system side, run a nomography, and we have the system calibrated. And well, there is more detail on the paper, and we can discuss a little bit more if you come on the process session just afterwards. But the key principle here is just to use some transparent plexical panels and to put them directly on the projector and to mount the camera on top of this to obtain this this installation. So there is not even 3D printing required, and it's really cheap, hands-free, and easy to adapt and replicate for novice users. We started to evaluate this design and this system thanks to a first experimental study with a few users. And so far, the results are really encouraging, because it was easy and useful for participants to use this system, and they really appreciated having something simple to use. So sharing a virtual cursor was enough for 3D guidance task about sailing knots. I will be happy to discuss more in details about this setup and this work in general in the dedicated room. So please feel free to come. And of course, questions are welcome. Thank you for your attention.
So again, questions from our side. Fatime, please go ahead.
Yes, thanks a lot for the presentation, Charles. And I really appreciate the system, because it seems like it's enabled of novice users to be able to use the, remote collaboration system. I have one question. Do you think it will be easy for novices to set it up as well? Or how do you think you can address that if it's already not addressed?
Sure. So the idea here is that you don't even need glue. In fact, we use double-faced tape. And well, maybe I can share this, well, not this one, here. You should be able to see it a little bit more in detail, yeah, here. So these transparent panels are just, well, plexiglass that we stick together, that I glued with, that I glued together, and we put it directly on the monitor. The idea is just to position it at the center so that the lens of the monitor will be aligned with the camera put on top of it. But really, you need, of course, a small projector, and you need a camera, but even basic hardware should be enough. We did not use something expensive at all. It was something we add directly on our shelves, and then just, well, position it to make sure that it will be correctly, both wheelchair will correctly reach the optical center. You can even look at it thanks to the reflection, and you will visually be able to inspect if it's correctly aligned or not. And then you're basically done. So there is nothing, as I was telling, there is not even a 3D printer required. It's really basic materials on, and that was the goal.
I see. Thank you. Thanks.
So just to finish answering, for now, we didn't evaluate it if novices could indeed perform this. It will be interesting to conduct a specific study about that, but it seems really simple. So I think it should be doable for most novices.
I see. Well, looking forward to see the experiment if you're planning to do it.
Sure.
Thank you.
Cool. Any questions from the audience? Okay, so we go further. The next poster is Fast 3D Point. It's point cloud segmentation for interactive surfaces. The authors are Everett, Christopher, and Florian. I'm not sure if Everett can duplicate himself and being in a breakout room and presenting here, so I'm not sure how they present this. But maybe before leaving the floor for them, I would love to personally thank the authors. They actually published their work as an open source. And for this, we are, as a community, we're really thankful for this. And for this, I leave the floor for them to present. Okay, for the courtesy of time, we can actually jump to the next one till he shows up at some point, hopefully. And with this, we go to the fourth poster. Actually fifth, but misordered. How content drives interaction with public displays. And this is actually quite interesting because it's from the same affiliation, so it's the Bundeswehr Uni in München, but it's a different group. So I'm really interested to see what others are doing in the group, in the university from our side. So Julian, the floor is yours.
Thank you very much. Yes, I am Julian Fiedkau. I'm the third author of poster number 5. The biggest chunk of the research that I'm presenting today was actually conducted by 2 students who I supervised, Benedikt Sprecher and Thomas Habekost, because they cannot be here today in person, unfortunately. I have volunteered, I think, to make the most of your time. It would be smartest, rather than trying to do an off-the-cuff presentation, if I play the presentation video that we prepared. It summarizes everything, and I think pretty succinctly, and it has a good length. So if that's all right with everyone, I am going to share my screen and just play the video for you. You can hear my voice anyway that way, and I can also show some subtitles, which might be helpful for some of you. Where is it? Here is it. Please let me know or interrupt if I need to adjust the volume in any way. And other than that, I will hit play. Digital public displays have become commonplace. Commercial and academic designers and operators of public screens have sought answers to the question of how these displays should work in order to drive user engagement. Research articles in this area predominantly talk about aspects of visual and interaction design, often disregarding the influence of what information, or content, is shown on the display. On some level this makes sense. Researchers aspire to find general design guidelines that can help engage users regardless of the specific purpose of the device. but this can lead to a blind spot if we ignore the content's influence on user engagement altogether. That is why we decided to survey the research landscape for answers on the influence of content on public displays. What can we conclude from existing studies? Are there specific kinds of content that work better than others? We started with a keyword search in relevant literature databases and aggregating search engines, going through about 200 potentially relevant results, and followed promising citations and references to articles that our keyword search had missed. Many of these results were empirical studies of public displays, and most of them did not discuss aspects of content at all. We filtered down the list to 21 articles that made some sort of claim or observation regarding the impact of public display content. The main results, each corroborated by more than one study, are 1. Local or locally relevant content can be perceived as more interesting compared to general content. 2. The same goes for timely relevant and up-to-date content. And 3. User-created content, albeit often overlapping with the previous criteria, has also been shown in at least 2 studies to drive increased user engagement. These results come with some caveats, and there are also studies showing contradictory results. More details on this can be found in our paper. Our main conclusion, however, is that aspects of content are under-examined and under-specified in existing research. We hope to inspire researchers in this area to consider aspects of content more explicitly in future studies, and to document them so this research gap can be filled. Because our literature survey was not fully systematic, but more of a semi-formalized literature probe showing preliminary results, we have received some pushback on the idea of presenting this work as is. Instead, a deeper systematic dive into the literature may uncover more results. The reason why that has not been done for this study is that our work was conducted by students in a university course, where a systematic literature review would have been out of scope. Because this work is unlikely to be continued by the same team, we present it for community discussion in its current form and hope that it can nonetheless inspire discussion. This video has been narrated by Julian Wiedkau. On behalf of my co-authors, Benedikt Sprecher and Thomas Havekost, I thank you for your attention. And with that, I will do my best to answer any questions that may pop up.
Thank you very much. Fatimi, you have something, I think?
Yes, I have. Oh, yeah. Maybe we can go ahead with the audience first. So Rina has a question, and I will go after her.
Hello. So Rina Webby, Dalhousie University. Just changed my affiliation, don't mind me. So I wanted to ask, what kind of upcoming work do you think would focus on content, or are you doing this upcoming work focusing on content? And have you looked at gaming literature? Because I know there is a few studies that have looked at how gaming is more attractive on large displays. And I was wondering if you kind of had a look at that area too.
Okay, for the first part of the question, there is no specific further work planned by this team. My students have moved on to other things, and I have also different priorities, unfortunately, in my job that I need to work on. So there won't be anything specific in that regard coming from us. We hope to encourage researchers who work on deployment studies with public displays mostly, to think about this topic of content, and also to describe their content strategy or their content parameters if they don't control it themselves on the displays that they evaluate. So we can hopefully in the future find out more how different types of content influence user behavior. And sorry, what was the second part again?
Have you looked at gaming or playful interaction?
I don't think we've seen any study specific to gaming. We have a little remark in our paper that the scope that we set was fairly narrow, focusing really on just public display evaluation studies for the most part. There's probably stuff to be learned from traditional advertising and similar areas as well. But that was not examined over the course of this study. If there were studies specifically about games on public displays that might make relevant claims to that effect, and I think we probably just missed them.
Thank you. Great work.
Thank you.
I just have a quick question. Do you have any guideline for if somebody wants to design public display content? What are the guidelines that you would think from the literature you looked at would be more engaging for audience?
That was actually our hope that we might conclude this work with some very specific guidelines on how public display content should be constructed or chosen. Unfortunately, what's currently there just doesn't allow for that kind of confidence in the guidelines that we were able to find. There were these 3 guidelines that we presented: local content, up-to-date content, user-generated content. Those were really the only ones where we could say with some certainty those were corroborated at least by more than one empirical study. Anything beyond that is, I would say, up for future work.
Thanks a lot. Great work, actually. Enjoyed reading it.
Thank you.
Well, thank you very much. We have a sweet poster coming up. It's a sweet spot, displaying interaction areas on everyday home surfaces using AR. It's from the Oldenburg group in Germany. I think this is the one running physically, and I think we have also a side channel from Heiko to present it virtually. And with this, I leave the floor for you. It's actually, we have a physical casting, nice. So Michael, the floor is yours, or the screen is yours.
Hi, everyone. I'm Michael Chamnora, and I'm representing our team from Oldenburg. So the way we're going to do this is I'll present here physically, then Heiko will be in the breakaway room to sort of answer some questions, but I'm also around for anyone who has questions on the floor. Okay, so the background of this project is related to the project on rich interactive materials for surfaces in the home. And with this, we were thinking about we have tabletop or table-like surfaces, and these can be used as interfaces to universally controlled devices in a smart home environment, right? But how do we do this? What can we figure out in order to make this work? So to realize this potential and enable furniture designers, we need to find data about which are the most reachable and accessible zones on table-like surfaces. So what did we do? We thought of representing this in VR and AR, all right? And we had 2 options, and which made us arrive to the question, how best can we visualize these spots of accessibility and with less clutter in AR and VR environments? So for those who can see the poster physically, we had color coding as well as icons, but we needed to figure out again with those 2 options, color coding and icons, how best can we figure out which one presents or gives the best results. And we tested these icons and color codes on 3 hypotheses. The first one was on error rates, where we wanted to determine whether the error rate on icon visualization is less as compared to the one on color coding. As well, the second one was on visualization time, whether icon visualization presented less time than in color coding. And the third was on using icon visualization, figuring out the usability score, whether it's higher when compared to using color coding. And how did we test this? We had 6 participants, 4 females and 2 males. And the participants were asked to detect appropriate sweet spots for the different contexts to figure out the 3 hypotheses I mentioned. And these were our results. So we determined that for the system usability score, the icon scored less than the color coding. So our hypothesis was false. For the second one, time to complete, again, this was false because the time for icon was more than the color coding. And on the last one, the error rate was it was false because the error rate for icons was more than for color coding. So the floor will be open for more questions. If you can read the paper, you get a bit more details about how we conducted the study, because we had focus group discussions. We had to analyze quite a number of videos about how people use and interact on their tabletop surfaces. So thank you.
Yes, so do you have any questions from the audience? So Fatimi?
Yeah, thanks a lot. Actually, this was a very nice paper, and we had visualization, which grabbed my attention, of course, because that's the area of my research. I'm wondering how did you choose the coloring for the red and the green, and do you think it would affect the experiment if you choose different colors, like a grayscale, which is easier to differentiate?
Okay, so you mean the colors for the color coding section, or? All right,
Yeah,
so we
exactly.
had some discussions about that, and I think one of the first things we were asking was for people with visual impairments that deal with, say, color blindness. We tried to find a color spectrum that would work best for them. But then in the group we were working with, we figured out that no one had such an impairment. So for this, since it was more exploratory at this stage, we just decided to use, in the paper we have more pictures that show the different color codes. So it was perhaps the theme that you see on the poster where we had green and shades of gray and orange. So it was in a way maybe arbitrary to try and find the most common primary and maybe secondary colors. Does
See,
that
yeah,
answer
because
your
as
question?
you mentioned, the color, yes, and as you mentioned, the color blindness between the red and green might be a little bit challenging, but yeah, I understand. It's exploratory at this stage. Yeah, that was great, actually. Thank you so much.
So maybe one final question from my side. So first, thank you very much for the cool work. It was really an enjoyment to read. So you had the hypotheses and they were all rejected. And honestly, I was actually surprised when reading the paper how they did not welcome, for instance, the salty spots or like the bad parts. From a discussion perspective, do you have kind of an in-depth insights about why did you reach these findings? Is it biased of the participant? Is it because how it's presented? I mean, Heiko has the background of the poster. I think this is how the visualization looks like. So it's fancy. I think if he had icons, I would feel like, yeah, it's icons. But do you think it's more understandable if you have the icon instead of because I mean, if no one knew the poster, I know the poster, so that's why I could relate to Heiko's background. But for others, it could be a fancy Zoom background, right? So if it's out of context, do you think icons would outperform the color mapping or the color coding or not?
That's what we thought. We assumed that, okay, icons, typically, I mean, as technology designers, we think icons are more better suited to use as metaphors to represent different things on an interface. But it seems users see and think things differently. So I think it is, or it was also a learning process for us, and we are perhaps going to explore more as we use some of these results in some of our current work. So I don't know, it's still puzzling as well as to why people would say maybe color coding is more simple and straightforward and easy to understand in place of icons.
Cool. Thank you very much, Michael, for the presentation. And thank you, Heiko, for the other visualization. Now it's not a cool Zoom anything anymore. But yeah, it's a really cool project. And I'm really looking forward to see how you develop your project further. Cool, thank you very much. And this brings us to the next poster, Touch and Explore, a VR game exploration based on haptic-driven gameplay. And this is presented by Lokesh Kumar from India.
Thank you. I'll share the screen. I hope you guys can see my screen. So I'm from India and this is my paper. So coming to the game, so this is the screenshot of the game taken in secondary camera. So you can see the player standing inside the obstacle space, and the light waves are the spots which he touched already. And this is how the game looks like. It's a basic simple game. Coming to game logic, players enter into VR space. There'll be no light and they have to touch the environment and explore the topology. So those topology will be revealed through visual cues. Those are the lights, and they have to complete the specific level. So this is how the game logic works. And maybe I can show you the game video. It will make more sense. Okay. I hope it was visible. And coming back to the presentation, so you can see like the whole game is about touching and exploring the space and then navigating through the space. So I kept the visuals very negligible so that they can get more experience through the touch. And every second inside this game is like a curiosity trigger. So this is how the game starts. The image in the right hand side. So you see only the instruction for specific levels in the game, and this is the whole setup. So HMD gear, VR controller, and the haptic prototype, which was a big part of our previous work. And coming to the inputs, so initially you are restricted to is interaction radius, that is your arm's length. And as you explore the space further, you can reach to more space. And normal teleportation of VR works once you discover the space. And as you see, the gameplay was explained in the video, and that's it. Thank you. Any questions?
Thank you very much, Fatime.
Yes, thanks a lot. This was also very interesting use of haptic for doing VR game. Just made me think, is it possible to, do you think, be used for people or to increase accessibility when playing games, the tool you made? And do you have any plan to pursue that?
Okay, so this was a part of exploration. So I didn't think much about scaling it up or for accessibility. So further proceeding the game, I'll be thinking about how to include accessibility in the game. So I didn't think much about it while I was designing.
Thanks. Thank you.
Cool. Thank you very, very much for the interesting presentation and for the interesting submission. And last but not least, I think we got Everett back, and he's going to present us fast 3D point cloud segmentation for interactive surfaces. This is poster number 4. And since Everett was not here when we first presented the poster, thank you very much for you and the team for sharing your contribution as an open source. I personally really do appreciate this. And with this, I leave you the floor for the presentation. We can see you, Everett, but we cannot see the slides. And we cannot hear you. still cannot. We can see the slides, but no voice, no audio. No. Okay, so I think for courtesy of time, I'm sorry, Everett, maybe we can have you after the demos. So sadly, you have some technical issues, but hopefully you can resolve it. So we have 2 demos, we can go for them, and then afterwards we check if you can present. Cool, but thank you very much for the submission and for the open source again. Okay, thank you again very, very much for the authors of the posters. You made a really, really cool submissions and a great session. I really enjoyed it. Thank you again, Fatimi, for it was an honor working with you. I think it wouldn't have been done without your support and you pushing me to get the reviews on time and not delaying anything. Thank you very much for that. And thanks to the organizers and namely Pavel for the invite. So sorry, Fatimi, you wanted to say something?
No, I just want to say same here. It was a pleasure working with you as well.
Thank you very much. And this brings us to the demos. And on behalf of the demo chairs, we're going to push for this. So we have 2 cool demos. The first one is adapting a floor sensor for autonomous robots in a smart building. Takashi, I'm really looking forward for your presentation. The screen is yours. Right.
Okay, I'm Takashi. I'm Oda. We are from Shimizu Corporation, which is a Japanese architecture, engineering, and construction company. So today we would like to demonstrate our floor sensor system. So this is a sensoring floor to detect autonomous robots. So nowadays, many kinds of autonomous robots are introduced to buildings, for example, office buildings and airport buildings. And now we have this guiding robot, and the other one is a delivery robot. So those robots are moving around in the building. But when at a crowded area or congested area, those robots cannot see around because their sensors will be covered by surrounding people or obstacles. In that case, we need to provide some environmental or infrastructure sensors to support them, to provide some location data or positioning data. But these days, many kinds of techniques using camera detection is introduced, but because rising concern of privacy, it's pretty hard to install many cameras in the building. So our idea is to use this floor sensor, and we can detect human beings and robots anonymously. That is our idea. So let me introduce about this sensor. It's named Fitchbeta, provided by a Japanese company, Toyo-Ken. And then actually it's an array of pressure sensors. So if I move on the surface, you are seeing the data, how it's detecting my feet, right? Okay, then this system has a basic function to detect footsteps. I will change it to that mode. So if I walk on the surface, it tracks my footsteps. Then even when multiple people move on the surface like this, it still tracks both of us like this. So our idea is to modify and update this system to detect not only human beings, but also those kind of autonomous robots. So let me show you the results first, and then I will talk about the details later. So now one of the robots move on the surface, and then the system detects. So its name is Sail. It's a gliding robot, and now the system is detecting that this kind of robot is on the surface. Because that is autonomous, maybe some people will need at the environment. Other case can take 5 steps and then also detect the robot. Right. Now we have another kind of robot that is a delivery robot. So let's try how it will detect it. So the name of that robot is Deli. Then, yeah, now the system detects it is Deli. Because of the difference of shape of wheels, allocation of wheels, it can detect which robots are on the surface. Okay, let me briefly introduce how we detected those robots. So now the system is showing raw data and this delivery robot move on the surface. So those blue dots are showing wheels of the robot. But the data is pretty unstable. So we changed the technique and then we currently using the transition of robot wheels. So we can show it with a visualization. So with transition, it's much easier to recognize the pattern of those robots. So that is our implementation. Then the system still has some limitations. For example, when the robot is on the edge or corner of the surface, the system cannot detect the robot because not all of wheels are on the surface. That is one of the weaknesses of this system. And when the robot is on the surface, but if it is staying at one point without movement, the system cannot detect that robot because now we are using transition of wheels. That is the weak point of this, but we are going to improve it with more experiments and tests. All right, now we succeeded to detect those two kinds of robots, and at the same time, it can detect our footsteps. So as future direction, not only just getting those input, but we would like to provide some feedbacks to interactive systems. For example, better human-robot interaction or human building interaction as well. Here we have elevators. So maybe we can make a better communication or interaction between the building facilities, robots, and human beings. That's our vision. So this is our presentation. Thank you very much.
Thank you very much for the cool demo. Do we have any questions from the audience? I think there is some physical audience raising their hands, I think, if I'm not mistaken. Exactly.
Yeah. You're right, I raised my hand. Apologies if you already answered these questions in the presentation, but what if you have multiple robots on the same floor? Are you able to distinguish between them somehow?
Pardon?
What if you have 2 or more robots on the same floor? Can you distinguish between them?
Yes, yes. If we have 2 robots on the surface, yeah, we can distinguish between them. But because
how do you distinguish?
Pardon?
How do you distinguish between them?
Because the shape of wheels, allocation of wheels are slightly different between those 2 robots. You know, the shape.
With those 2 robots, but what if you use two identical robots? I mean, robots with the same configuration of wheels. Do you then have any means of distinguishing?
Yeah, if they have the same structure of wheels, we cannot recognize that. But still, we can know that if it's a human being or a robot. So that is one of the limitations of this system. Yes, that's true.
Okay. Thank you.
Thank you.
So we have one question. We can take it super quick from Rena, and then if you have any further questions, you can go to the breakout room. So Rena, please.
Actually, my question was about having multiple robots. I was going to ask how many robots can the floor sense, and for the floor configuration, is there like a maximum amount of tiles before you start having problems?
Well, now this system only run about those two robots. So as long as we have those kinds of robots on the surface, it can detect. Then maybe there are no specific limitation. As long as they can, put on the surface, it can recognize. Yeah.
Thank you very, very much, Takashi, for the really cool demo, really cool work. And last but not least, the very last thing in this session, it's the last demo, and sadly for Everett, for the technical issues, maybe you can try to catch him in a breakout room. Hopefully it works. But with the very last thing we have, of course, but not least, we have the last demo, teaching conversational robots in a museum exhibition with interactive surfaces. And this came all the way from Brazil, from IBM Research. And with this, I leave the floor for Mauro, I think.
Yes, thank you. Can you see my screen?
Yes, we do.
So my name is Mauro Pichiliani, and along with Heloísa Candelo and Claudio Pinhanes of the IBM Research Brazilian Laboratory, we are here to present this demo of teaching conversational robots in a museum exhibition with interactive interfaces. So I was actually going to the museum to present this demo live, but today is a national holiday in Brazil, so the museum is closed. But because of that, I will present a short video and then explain a little bit about the system. And for those who want to interact with it, I do have an online link, and the interaction can be done in the breakout room, right? So let me play this video. It does.
We cannot hear it. If there is an audio to it, we cannot hear it.
Oh, okay. So not sure how I can. Let me see if I can.
On a Zoom presentation, when you have screen sharing, there you will have their options, and in the options you should have enable sound.
Okay, thank you for this tip. I will try again. Let's see. Are you guys hearing now?
Bem-vindos! Estou pronto para mostrar tudo o que eu sei.
Estamos aqui no Museu Catavento, em São Paulo.
E nós somos pesquisadores da IBM Research no Brasil. E somos os responsáveis por este incrível projeto que objetiva democratizar a inteligência artificial.
If machines talk like us, do they think like us? This demo aims to teach AI concepts to 9 to 14 years old children in 30 minutes.
Qual que é a melhor forma de aprender algo? É ensinando. Então a gente vai ensinar as crianças a ensinarem os robôs como entender os seres humanos. Vamos ver como este projeto funciona.
At first, the robots talk to each other about the museum's contents. Visitors can learn about AI asking questions to the robots interactively.
Essa eu sei. As hemácias, também conhecidas como glóbulos vermelhos, são células essenciais que transportam oxigênio e possuem hemoglobina, proteína de cor vermelha.
Sabe uma coisa interessante sobre o sangue? Ele é vermelho por causa dos glóbulos vermelhos, também conhecidos como hemácias.
Este trabalho utiliza o Watson Assistant para processamento natural de linguagem e o Text-to-Speech da IBM Cloud para a geração da voz dos robôs. A arquitetura do sistema é feita em microserviços utilizando tecnologias como o Node.js, Python e outras tecnologias criadas exclusivamente pelo Laboratório de Pesquisa da IBM do Brasil.
The kids will learn playfully and innovatively what's AI. This project is also creating and testing new theories and technologies in the area of interaction between people and intelligent computers.
Okay, so this was the video presentation, and this project is happening in a museum, like I said, and is expected to be open next year due to the pandemic. We have this two ways to interact with the exhibition. One is what we call spontaneous visits, where the users just go to the section and use the touch screen to ask robots questions. The questions that the audience can ask is about the content of the museum. And then the robots ask the questions. For each robot, you have a confidence level that explains how much confidence the robot have in the answer. This is related to important machine learning concepts, such as the probabilities and other aspects. And on the second way of interacting with the museum exhibit, the museum receives groups of children, mainly from schools, and they do a guided visit. On this guided visit, the monitor of the Catavento Museum explained to the participants how they can train the robots to increase their confidence level. The training is based on a pair of questions and answers. Basically, the monitor explained to the groups of kids that they have to provide a question to an existing answers. And as they are providing questions to the existing answers of the robots, they are training the robots. And after the training session, that can be done on 3 different stations, each one capable of using interactive touchscreen surfaces. After the training, the monitor shows to the group of kids that they train the robot and the confidence increases. And the monitor also explains that the concepts of machine learning, such as confidence level, such as that robots can learn from our data and that robots can make mistakes, are presented during this exhibit. So like I said, I have an online interactive demo that I will present on the breakout room with a link that anyone can train and see how the robots react to the training when they are answering the questions. And I'll be happy to answer any questions you may have. Thank you.
Well, thank you very, very much for the interesting demo. For courtesy of time, we would have to end this. Thank you very much for being a great audience. Thank you for the posters and for the demo presenters and authors. Yeah, thanks for the people behind the entire organization. And with this, I hand over to Pavel.